Hello everyone and welcome to the Internship Studios session on Identity and Access Management in AWS. So this will be the following session from our previous session on AWS fundamentals. So let's quickly go into the introduction of IAM. So let's directly jump into the definition of IAM. So the first question is, what is identity and access management in AWS? AWS Identity and Access Management, simplified as IAM, is a service provided by Amazon Web Services that enables you to securely control access to AWS services and resources. IAM allows you to manage users, groups, roles, and permissions within your AWS environment. So let's imagine we have a hotel called Cloud Hotel. So you want to manage who has access to different areas of the hotel to ensure its security and smooth operations. So AWS Identity and Access Management is like your control center for this. Let's imagine that it is some kind of a control center within that hotel. So the first uh, option we have is of users. So since in the definition it says that IAM allows you to manage users. So let's take the first component of users. So imagine them as your guests and staff. So the guests who are checking in at the hotel and the staff who are managing that hotel. So in the cloud hotel, guests checking in and the staff working at the hotel in various roles, like we have the janitors, like we have the receptionists, we have the room boys. So imagine them who play various roles. They are like the IAM users. So each user has a unique identity. They have a unique role to perform and fulfill their duties, such as a room key for guests or staff badges for employees. So each user has to fulfill their role appropriately from the time we check in at the hotel to the time we check out from the hotel. So we have a lot of users who will be interacting with similarly. And the next we have is groups. So groups we can say, like we can think them of as categories. We have various categories. So, guests staying in suites, standard rooms, or penthouses could belong to different groups. Similarly, like in the hotel, we have these staff roles like front desk, cleaning, or management are organized into groups. And similarly, like the customers staying in hotels, like if you go to a five-star hotel, they have different types of room classes, right? They have suites, they have standard rooms, or they have ultra luxury offerings as well. So groups are nothing but a different categorized uh, set of sections, you can say. And the next one we have is roles. We can assume roles has the different job responsibilities each thing has. So the roles in IAM represent the different job responsibilities. So similarly, staff roles we have the housekeeping service, we have the front desk manager service in the hotels. So they are given very specific roles with their specific duties. So they ensure that they can perform those duties without any unnecessary problems. You can say, like each one has a defined set of role they need to fulfill so that there is a smooth functioning of the hotel. The next section we have is policies. You mean the access rules, like who has access to what section of the hotel. So, policies are like rules governing the access. For instance, a policy in terms of a hotel can state that only cleaning staff can access guest rooms for housekeeping purposes. None other than the cleaning staff should enter because we have various people, right? The person who you meet at the front desk, so he must not be having access to enter into the hotel. Only the cleaning staff and other room boys can enter the hotel if you have any convenience related activities to take care of. So policies define who can do what in the cloud. So in our case, a hotel, to mimic that scenario. And the another important point is permissions. So in the context of the cloud and the hotel, permissions here mean room access rights. So permissions are the specific rights or access levels, you can say. For example, a permission might grant the ability to enter a particular room or use certain facilities. So IAM in the aspects of cloud ensures that users, whether guests or staff, have only the necessary permissions for their roles. So this is regarding the permissions and an overview of what are users, groups, roles, permissions and policies. So to let you know, there is also an extra added component of security called the multi-factor authentication, which is an extra security layer. So MFA, as it is short form, it adds an extra layer of security. Like for example, you may be having the Google Pay application in your smartphones, right? It's a payment related application. So once we enter into that, we are again uh, required to enter the pin code for that to smoothly access that. And once again, when you are making the payment, you are again required to add a 4 or a 6 digit pin accordingly. So there are multiple factors of authentication, you can say. So not only a single time. So similarly, like if you take it into the example of a hotel, it's like requiring both a key card and a pin to access the room in your hotel. So it ensures that users can authenticate their identity using more than one method for added extra security. So yeah, this is pretty much about the introduction of IAM in AWS. So quickly we'll see the idea behind implementing IAM in AWS. So diving deep into the question of the idea behind implementing IAM in AWS. So can say that it is to provide a robust and secure way to manage access to AWS resources. Like whatever the resources we create in AWS, they need to be monitored, right? Like who is creating and what they are creating. So the who and what are two very important parameters here to keep them in check. So the IAM here serves as the gatekeeper. So it controls who can do what in your AWS environment. So it is also the implementing AWS identity and access management is also driven by the need to establish a secure and controlled environment within AWS. So IAM acts as the guardian regulating access to AWS resources and defining who can perform the specific actions. So it has its key concepts such as centralized control, granular permissions, and identity management, which ensure that users have precisely the access they need. No more, no less. So IAM enhances security through features like multi-factor authentication, which we saw in the previous slide, and secure key rotation, which we'll see in our hands-on session. The service facilitates auditing and compliance by generating detailed docs and integrating with AWS Cloud Trail, which is another service by AWS. So traditionally, IAM also supports collaboration with cross-account access and seamless integration with external identity providers. So we have MFA providers like Microsoft Authenticator and Google Authenticator, which AWS also supports for additional sign-in options. So this promotes a streamlined and secure approach to identity and access management in the AWS cloud. So overall we can say that IAM is fundamental for enforcing security best practices and aligning access permissions with organizational policies and compliance standards in the AWS ecosystem. So looking into this table, we firstly have this AWS identity and access management. So it says apply fine-grained permissions to AWS services and resources. Fine-grained means to the extent like we can deeply specify and we can customize the permission such that we can assign permission at the resource level, not at the account level. You mean, for example, take an S3 bucket. So we also can give permission such that at the bucket level also we can specify who and who are eligible to do what kind of operation on that bucket. So we'll see what that S3 bucket and all in the later sessions on simple storage service, which is S3. I am just giving an example on to let you like imagine like what kind of permissions we can execute there. So this is the outer structure of AWS IAM. Uh, the next thing we have is who. So workforce users with AWS SSO and workloads with IAM roles. So AWS SSO means single sign-on, and here we can control who has the access to do what. So the next thing is can access. So we have a list of permissions with IAM policies. We look at permissions and policies in the later slides. And what means the resources within your organization. So resources may be your S3 bucket, your EC2 machine, anything, any resources. So the IAM will govern who can access what. So in simple words you can say. So coming to our next slide, which says why to learn identity and access management. So we have uh, important points here, like why we need to learn. The first point is security and compliance. So it says IAM is at the core of securing cloud environments. Understanding IAM in the cloud allows you to define and manage access controls, ensuring that only authorized users and services have the necessary permissions to access resources. So this is fundamental for maintaining security and meeting compliance requirements. So when you operate on the cloud, it may be AWS or Microsoft Azure or Google Cloud. So every cloud has their own identity and access management solution. So it's very critical to understand that we need to be before starting on to deep dive into the cloud. So the first important thing is to learn about the IAM of that specific cloud because it it is kind of you can say it is the foundation of learning the cloud. So without knowing IAM, you can't uh, like do anything you can say literally because if you just ignore this IAM aspect, so anyone can do anything, because if you have, since it is a the potential of costs or threats that is involved in the cloud, you can say, because if you give access to it to a layman, you can say they can spin up something large which involves around lakhs or crores of rupees, and you don't be knowing, like, at the end of the day it will be a big hole in your pocket. So it's always a best practice to say that only authorized and learned users and services have the necessary permissions to access resources. So once again, it's a fundamental for maintaining your security and compliance requirements. And the next one is the least privilege principle. So IAM in the cloud enables the implementation of the principle of least privilege by granting users and applications only the permissions they need to perform their tasks and nothing more. You reduce the risk of unauthorized access and limit potential damage in the event of a security incident. So, what this definition says is you only need to assign a person what he is meant to do. In the context of a hotel, you can say we have this front desk executives who are only authorized to process your check-in requirements, you can say. Like they need to validate your ID proof, give the room key. That's it. They should not be authorized to enter your rooms and be involved there actually. So the room related activities must be taken care by the housekeeper. So similarly in the cloud, if you can say, like, a person is assigned to only spin up an EC2 machine and not create a S3 bucket, we should assign him the EC2 related roles only, not the S3 bucket related roles. So we are restricting him to the privilege of only operating on the EC2 instance, not on the S3 bucket. Because if he gets involved in creating the S3 bucket, then it's a defying of the least privilege principle. So the the crux of this principle is people should be granted and assigned only the permissions they need to perform their task and nothing more. So this is about the least privilege principle. So coming to the third point, which is centralized management. So cloud IAM systems provide centralized management of user identities, access policies, and credentials. This centralization streamlines administration, making it easier to add or remove users, adjust permissions, and monitor access across various cloud services and resources. So when we jump into the hands-on session where I'll show you in the console, you can see that Cloud IAM has its own interface where, like, it has a centralized solution where we can add users, we can remove users, we can add them to a group, we can attach policies to that group, we can attach policies to the IAM users and roles, etc. So this acts as a centralized hub so that if you, like, in a big enterprise where there are thousands and thousands of developers, cloud operations team, DevOps engineers. So it becomes very important that you have a centralized team that manages this IAM. So AWS has provided this beautiful console and a separate section of IAM where you can actually have a separate IAM team itself to manage the users, because there will be a couple of people like joining the company and leaving the company. So if you don't have a neat centralized management, then it becomes very difficult to manage the users as well. and monitor their access. So it's very important to learn IAM in the aspect of centralized management as well. So these were the three important points. So there are multiple other features as well, like why we need to learn identity and access management and what are the other benefits of them. So the next one is multi-tenancy and scale. Cloud environments often involve multi-tenancy, where multiple organizations share the same infrastructure. IAM helps ensure the secure isolation of resources and user identities in a multi-tenant environment. Additionally, as cloud environments can scale rapidly, IAM provides a scalable way to manage access controls without compromising security. So, first we need to understand multi-tenancy. So, multi-tenancy in the context of AWS and access identity and access management, it refers to the capability of supporting multiple independent entities or tenants, such as organizations or customers, within a shared IAM environment. So each tenant operates as if it has its own isolated IAM setup, allowing distinct management of users, groups, roles, and permissions. So in a multi-tenant IAM model, the main point is it comes is isolation. So tenants are isolated from each other and changes made by one tenant do not impact the IAM configurations of other tenants. So this isolation ensures the privacy and independence of each tenant's identity and access management. The other one is customization. So each tenant can customize its own IAM policies, roles, and user management to suit its specific requirements. So this flexibility enables diverse organizations sharing the same AWS infrastructure to tailor IAM settings according to their unique needs. And one more important aspect is resource segregation. So IAM ensures that resources are properly segregated between tenants, preventing unattended access. So each tenant has its own set of users, groups, and permissions, maintaining distinct boundaries in a shared environment. So one more we saw about multi-tenancy just now, and the other important word here is scale. So scaling in IAM, it refers to the system's ability to handle the growth in the number of users, groups, roles, and permissions as an organization or AWS environment expands. So one beautiful aspect about IAM is it is designed to scale horizontally, accommodating a growing number of entities and maintaining performance and responsiveness. So the key aspects of scale in IAM also include user growth, because as the number of users increase year by year, IAM can seamlessly handle the provisioning, authentication, and authorization processes. So the system is designed to efficiently manage a large user base without sacrificing performance. So we also have the possibility of group and role expansion. So with the growth of an organization, because we have enterprises due to the disruption of technology nowadays, there would be many employees, right? This year there would be around 500 employees, and in the coming year there would be 1,000 employees. So with the growth of the organization, the number of groups and roles might also increase. So IAM scalability ensures that the management of these entities remains efficient and responsive even as the organization grows. So one more parameter is policy management. So as more policies are defined to control access to resources, IAM scales to manage and enforce these policies across an expanding set of users and roles. So we also have integration with services as the next part. So cloud IAM is tightly integrated with other cloud services and features. Understanding IAM is essential for effectively utilizing various cloud resources, services such as storage, compute, databases, and serverless computing, while maintaining a secure and well-governed environment. So, IAM, I think it is interwoven in all the services. So, we can also uh, integrate with other services such as storage services. For example, we have S3 EBS and others. Related to compute, we have EC2, EKS, we have ECS. So it helps us to fine-grainedly operate in the cloud environment. And the next we have identity federation. It says cloud IAM often supports identity federation, allowing you to integrate your existing identity systems with cloud services. This enables single sign-on and seamless access for users, whether they are accessing resources on premises or in the cloud. So you'll understand identity federation bit deeply. So identity federation in AWS, it's a mechanism that allows external identity systems to grant temporary limited access to AWS resources without the need for creating and managing AWS specific identities. So this enables users to access AWS resources using their existing credentials from an external identity provider. So rather than relying solely on AWS specific usernames and passwords, so users can leverage external ID providers. So we have like a couple of identity providers. So they are an external system actually that manage user identities and authentication. So we have a couple of examples like we have Microsoft Azure Active Directory, we have Google, or we have an on-premise Active Directory as well. So we also have the concept of federated users. So federated users are users in AWS who gain access based on temporary security credentials obtained from the external IDP, say Microsoft Azure AD. So these users do not have an AWS specific identity, but with the help of these federated users, we can be granted access through the federation process. So we can also establish trust relationship as well. So trust relationship is established between the AWS account and the external ID provider. So this relationship defines the conditions under which the AWS account trusts the external IDP to authenticate and provide temporary security credentials. So we also have the provision of STS, which is Security Token Service. So the AWS Security Token Service, it issues temporary security credentials to federated users after successful authentication from the external IDP. So these credentials include access key ID, secret access key, and a session token. We'll be seeing the access key and secret access key during our hands-on session. So these uh, what you can say, these all identity access related things come also with the temporary security credentials. So once authenticated and authorized, the federated user receives temporary security credentials. So these credentials are valid like for a specific duration at around 1 hour, and these are used for accessing AWS resources. So all these temporary security credentials have a limited time span. Uh, the federated users must re-authenticate and request new temporary credentials before the current ones expires, because this actually enhances security, because if some password or credential gets into the hands of someone, then there may be very bad consequences. So this actually enhances the security by minimizing the window of vulnerability associated with long-lived credentials. So, and the one more awesome feature here is the automation and DevOps practices. So IAM plays a crucial role in automating the management of infrastructure and applications in the cloud. So as organizations embrace DevOps practices and infrastructure as code, you mean we have this DevOps ISA tools like Terraform, Pulumi, where you can write the infrastructure configuration in code actually. So IAM policies are defined programmatically to ensure consistent and secure access controls throughout the development lifecycle. So these are like around important points. We saw around seven important points here, which make us learn why AWS identity and access management is important in the management of cloud as a whole. So before getting into the security aspects in the cloud, we understand the security, how security was governed before the cloud came into existence. So, before the widespread adoption of cloud computing, organizations actually implemented security measures using traditional on premises infrastructure. So, the security landscape focused on safeguarding those physical servers, networks, and data centers. So there were a few key aspects as well, like how the security was built before the cloud. So the major one was the physical security. So security began with the physical protection of data centers. So access to server rooms, data storage facilities, where was very restricted earlier. So they often required like those key cards, biometric authentication, and other physical access controls. So the next came the firewalls and network security. So firewalls were deployed to monitor and control traffic between internet networks and the internet. So network security measures involved setting up virtual private networks, VPNs, you can say, which safeguarded the flow of information. So there were also intrusion detection systems, which mean like some safety alarms. If someone unidentified enter the place, then there were kind of some sound alarms or beep noises which would trigger, which safeguarded the unauthorized access and cyber threats. So there were like perimeter defense as well. So organizations relied heavily on perimeter defense strategies. So considering the network's outer boundary has a primary line of defense. So this included firewalls, routers, and other security appliances to filter and inspect incoming and outgoing traffic. So this was regarding the perimeter defense. We had antivirus and anti-malware softwares as well. So these antivirus and anti-malware solutions on individual servers and endpoints. Regular updates and scans were essential actually to maintain the effectiveness of these tools. So there is also encryption actually. What encryption means is to safeguard the data. Like the data needs to be protected during transit and at rest while we do this internet communications, right? So there are two layers actually, SSL, which is secure sockets layer, and transport layer security, TLS. So these two are primarily used to encrypt communication over the internet earlier. So while file and disk encryption ensure the confidentiality of stored data. So there were a couple of backup and disaster recovery solutions as well. So these were very fundamental components of security back then. So organizations maintained backup copies of critical data to ensure business continuity in the event of data loss or system failures. So there was patch management involved as well. So regular software updates and patch management solutions were critical for addressing vulnerabilities. So there were actually system administration jobs earlier. We used to see a lot of system administrator jobs earlier. So They were fixing these servers physically, they were doing this patch managements. So everything was done on premise itself in the data center. So again, because since these were all handled in the on premise setup, so this process actually required very careful planning to avoid disruptions to business operations. So there were a lot of incident response and monitoring teams overseeing this security as well. So security teams implemented incident response plans, and they monitored network activity for signs of potential security incidents. So there were intrusion detection systems and log analysis tools to identify and respond to security breaches. So while these security measures were effective in the on-premises world, so the shift to cloud computing actually introduced new challenges and opportunities. So cloud security models have evolved to address the unique aspects of virtualized, scalable, and distributed infrastructure. So there's also a alternate word to cloud computing we can say as distributed computing. So since new technologies and new practices came, so does the security of the cloud here. So I have taken around these 3 points, which are access control, security, personnel, and firewalls, which we discussed this just now. So coming to the next one, which is security in the cloud. So the first thing is the identity and access management. So we use IAM services to control access to cloud resources. We implement the principle of least privilege to grant users and services only the permissions they need. So we enable multi-factor authentication for enhanced user authentication. So similarly, we use data encryption here as well. So we encrypt data in transit using protocols like secure socket layer and transport layer security for communication. We encrypt data at rest using encryption mechanisms provided by cloud storage services. So we make encryption keys securely leveraging cloud-based key management services. So there in AWS we have Cloud KMS, which is a key management service which helps us manage encryption. Coming to the third aspect, which is network security, we implement firewalls and network security groups to control incoming and outgoing traffic from the internet. So we use VPC, which is virtual private cloud, or similar constructs to isolate and segment networks in the cloud. So we have other solutions as well. We have logging and monitoring. So we'll set up comprehensive logging for cloud service and infrastructure so that we'll have a detailed history of all the events, all the computing events, if there are any downtimes or if there are any resource related issues. So we'll maintain those logs in the cloud environment. So we also use security information and event management tools to aggregate and analyze logs. We have SIM tools from Microsoft and other cyber security companies as well. So we also implement real-time monitoring for suspicious activities and security incidents. So there are like observability tools. For example, we have Dynatrace, we have PagerDuty, we have Grafana, we have Prometheus. So these are a couple of monitoring tools that keep in check the cloud environment for any threat related activities. Uh, and we have data backups and recovery model. So data security is also taken care of in the cloud where we implement a regular data backups using cloud backup services because data is really important for critical business applications nowadays. So enterprises make it a point that data is backed up regularly using regular intervals. So there are some test data recovery processes to ensure business continuity as well. So we also store backups in geographically diverse locations for resilience. So, as in the introductory sessions, we saw about availability zones and regions, right? We can make it a best practice that our data is stored across multiple regions and diverse locations. For example, if we are storing data in the US regions, for example, North Virginia, so we can maintain another backup of the data in India or Brazil or Japan instead of keeping in the United States itself, because there might be some political events, there might be some unforeseen physical mishappenings which may happen. So it's always a best practice to keep our data backups in geographically diverse locations. For resilience, resilience means fault tolerance. So we have another aspect of identity federation. So we can integrate identity systems with cloud services for seamless access. We already saw like we have identity IDP providers, Microsoft Azure Active Directory and Google Directory. So we can implement single sign-on to simplify user authentication across services. So we can utilize identity federation protocols such as OAuth and SAML, which are industry leading protocols. And we can also set up compliance and governance with the help of this. So these were a couple of security practices which are undertaken in the cloud nowadays. We'll move to the next slide. So we'll see in terms of IAM, these are the two keywords which are very important. The first one is authentication and the another one is authorization. So let's read out the definition and I'll explain it deeply. So the first one is the authentication. So authentication in the context of cloud computing refers to the process of verifying the identity of users, systems, or entities attempting to access cloud resources or services. It is a fundamental aspect of security that ensures only authorized individuals or entities can interact with cloud environments. Authentication is typically based on the presentation of valid credentials to prove the claimed identity. So let's understand the concept of authentication. Like, let's take it as a secure entry process for a high security facility. So what all we can imagine while entering a high security facility, like which is uh, like level 3 or level 4 security as per US standards. So the first thing that comes is identity verification. So imagine a facility with restricted access. So individuals seeking entry are required to present a valid identification card. So you maybe think it as a passport or your national identification card such as Aadhaar, PAN, any like a personal identification card. So this initial verification ensures that the person is who they claim to be. So the who is taken care of here, like it would be having their name, their address, and all their other personal details. So the authentication factors that we check here are to enhance security. A dual factor authentication system is implemented. So in addition to presenting the said ID card above, individuals must enter a unique personal identification number known only to them. So like the pin may be their date of birth or any like number which they can remember for a very long time. So this two-step verification process significantly reduces the risk of unauthorized access. So the another one is biometric authentication. So in advanced cases, the facility might employ biometric authentication methods such as fingerprint or retina scans. For example, in airports or any other government public sector undertaking units. For example, we have IOCL in India, which are petroleum units. So these require some higher level of security for employees entering. So they may be employing fingerprint or retina scans. So these unique biological markers, they add an extra layer of identity verification, making it existingly difficult for unauthorized individuals. So in essence, the authentication in the cloud operates with a similar philosophy. So utilizing various factors, technologies and best practices to ensure that only authorized entities gain access to digital resources. So this rigorous authentication framework is fundamental to maintaining the integrity and security of cloud-based systems and data. So the next thing, so hope you understood authentication. So coming to the authorization, we see that authorization in the context of cloud computing refers to the process of granting or denying access to specific resources or actions based on the authenticated identity of users, applications, or systems. So while authentication verifies the identity of entities accessing cloud resources, authorization defines the permissions and privileges associated with those identities. Authorization ensures that only authorized entities have the necessary rights to perform specific actions within a cloud environment. So let's get this point with a simple explanation. So we'll delve into the concept of authorization with an analogy here. So imagine you are in charge of a high security library where each section holds valuable and sensitive information. Authorization in this context is the process of granting or denying access to specific sections of the library based on an individual's credentials. So you can use library sections as resources like in AWS. So think of each section in the library as a resource. For instance, financial records, there may be some classified documents or historical archives. So each resource holds valuable information that should be accessed only by those with the appropriate permissions. So we can use the library card of individuals as credentials. So individuals who want to access to the library must possess a library card. This card represents their credentials. The card may be having a number, a unique number for each person. So the card itself doesn't grant access to all sections. It merely serves as proof that they are library patrons, like they have subscribed to the library. So we can also, as a fine grained measure, we can also access permission levels on the library card. Now imagine that each library card has different permission levels. Some patrons may have card with access only to the public areas, while others with higher authorization levels can access restricted sections. The permission level on the card dictates the areas they can enter. So we can also list out a access control list. So for example, you as the library manager maintain an access control list that specifies which library cards have access to which sections. This list serves as a detailed record of authorized access and restrictions. So when someone enters or want to enter a specific location, you check their library card. So this is similar to a system verifying user permissions in real time based on the ACL. So if their card grants access, they are allowed into the section. Otherwise, entry is denied. So in essence, authorization in the cloud operates much like managing access to different sections in a high security library, you can say. It involves defining permissions, checking credentials, maintaining access records, and adapting access levels based on changing needs, all to ensure that individuals access only the information and resources for which they are authorized. So hope you had a understanding of authentication and authorization process in the cloud. So coming to the security credentials in AWS. So we'll discuss here like what are the important security credentials that you can have handy so that we can enter into the AWS account. So the first parameter is the unique username and password. The second one is the MFA on top of our unique username and password. And the third one is the access keys and secret keys. So we'll see how each of them has its importance. So to log in into AWS, after creating the AWS account, we should log in as a root user. The username must be unique, most probably your unique Gmail ID, and your password must be strong enough. And there should be MFA enabled for added layer of security. For example, after login into the AWS account with your username and password, you can have an external MFA configured so that if your credentials get into the hands of someone, then you are, unless you operate and approve via the MFA app, there won't be any issues. So also there are access key and secret keys. So imagine like they represent the managerial authorization of a hotel, you can say, like in the context of in the analogy of hotel, according to the security credentials, you can say that there are some specific designed keys to access critical hotel management functions. So we also can leverage access keys and secret keys for added security. So these are the main three login options available in AWS. So coming to how to access IAM in AWS. So the first thing is the AWS Management Console. So we saw the Management Console in the AWS Fundamentals session. So we can directly open the Management Console and get into the IAM section and get hands-on from there. And next is the CLI access, which is also called the programmatic access. CLI means the command line interface. So from the our laptop or computer terminal locally, we can interact with the AWS once we have the AWS CLI installed in our local computer. So these are the main two options to interact with IAM in AWS. So let's get hands-on on IAM. So let's quickly open the browser and get into the AWS Management Console. So we'll quickly go into the browser now and log into our AWS account. So I already like visited as I showed you in the previous sessions, like we have the console home and here it shows the recently visited portals. So for the simplicity, I'll again get into the IAM. So we'll type as IAM manage access to AWS resources. So it is the IAM dashboard. It has some security recommendations. It says add MFA for the root user. It enables, as you saw, it enables multi-factor authentication, and it improves security. Like we can add MFA. For example, if we go to add MFA, We can assign an MFA device. We can enter your name, for example, internship studio. I always suggest to use MFA for your logins. So we'll download an authenticator app. We'll select the authenticator app has a MFA device. So we have three more devices, like we have this authenticator app, we have a security key, and we have our hardware TOTP token. So we'll go with the authenticator app. So it says install a compatible application such as Google Authenticator, Duo Mobile, or Authy app. If you can see, there is a list of compatible applications as well. So there are like it's the official AWS documentation. So available MFA methods for IAM. We already saw the FIDO security keys. We have virtual authenticator apps. So for both the OSs, for Android we have Twilio, Authy, Authenticator. We have Duo Mobile, we have Microsoft Authenticator, we have Google Authenticator, and Semantic VIP. For iOS we have this all the similar applications, and we have hardware TOTP tokens. So I would suggest you to download the Google Authenticator for now, since it's very easy to use. So we'll go back to the management console here. So hope I hope you have already downloaded the Google Authenticator app from the Play Store or App Store respectively. So I suggest you to install the application, and once you install the application you will get a sign in option. So sign in accordingly with your Gmail account, and then you have the option in the mobile that set up your first account. So you can use the QR code or setup key in your two-factor authentication settings. So I suggest you to scan a QR code. So the our first step is done here, like we have installed the application of Google Authenticator, and we'll open your Authenticator app and choose QR code on the page, and then use the app to scan the code. So I will click the show QR code here, and I'll click the scan QR code in my phone. So yeah, I got the first MFA code here. uh, let's 65647. Wait for the code to get completed, and wait for the new code here. Yeah, we have got the new code 6. So now we have completed all the three steps. Now hit add MFA. So yeah, you can see that here our MFA is set up. So the device type is virtual, and we have the identifier of ARN. So we have this internship studio has our identifier name here. So I always suggest you to get the MFA as soon as you set up your account. It's a very straightforward step which will help you in your security. And one more thing is, if you want to get the programmatic access to AWS, like for example, I'll show you my terminal here. So if I want to get the AWS access from here, like I want, since people coming from tech background already who are Linux operators who are comfortable with command line interfaces. They don't want to use the management console or just want to do the AWS related operations from the command line. Then we have this facility of having the AWS CLI. So we can install the AWS CLI and get hands-on from there, like using the commands. They already say that using access keys to send programmatic calls to AWS from the AWS CLI. So they also say you can have a maximum of two access keys at a time. So access keys for people who are comfortable with the CLI access, we can authenticate with AWS from the CLI as well. So for that also we'll create one access key. So it says alternatives to root user access keys. Root user access keys are not recommended. So we don't recommend that you create root user access keys because you can't specify the root user in a permissions policy. You can't limit its permissions, which is a best practice. So instead use alternatives such as IAM role or a user in IAM identity center which provide temporary rather than long-term credentials. So we'll not, since it's against the recommendation of AWS, we'll cancel this option. Since we'll be mostly interacting with the AWS management console, we'll not go ahead and create the access key here. So then this is the dashboard. So we have all the credentials related things here. We have our account name, we have our account ID, we have our email address, we have the canonical user ID. And in the left side, we have this access management setup. We have this user groups, we have users, we have roles, we have policies, we have identity providers, we have access reports, we have access analyzer, we have the credential report, we have the service control policies here. So let's first go to the users. So since it's a fresh AWS account, we don't have any user created at all. So what we'll do is we'll go ahead and first create our new user in the AWS. So what I'll suggest is uh, we go to this orange create user button. So username we need to type, it should be unique. It says the username can have up to 64 characters, like valid characters are capital A to Z, small a to Z, numeric numbers from 0 to 9, and any special characters such as addition symbol, equal to symbol, comma. You can use any of this. So I will use the username as internship studio hyphen user. So it says provider user access to the AWS management console. So I'll check this box. It asks the question, are you providing console access to a person? Specify a user in identity center, which is recommended. We recommend that AWS recommends that use identity center to provide console access to a person. With identity center, you can centrally manage user access to their AWS accounts and cloud applications. So we'll select this as the recommended option and we'll go to next. This will take you, since we already selected the manage in identity center, we'll go to the identity center now. So first we need to enable the identity center. uh, it's recommended that we should enable with AWS organizations, but since we don't have an organization setup, we'll enable in only this account. Just hit on continue. So it's always a good practice to add tags because you know who is created. So the normal best practices will hit the created by tag always. The key is created by value is internship studio, and we'll do enable. So this is the dashboard of the IAM Identity Center setup. So once we are done with the Identity Center, come back to the IAM console again. So we'll firstly create a new user here. So we'll do create user. We'll do internship studio. And we'll not check it for now. It's anyway optional to provide our access to the user access to AWS management console. Next. It says add user to an existing group or create a new group. We recommend using groups to manage user permissions by job function. Get started with group. So before creating user, we'll create a group. So these are all the permission policies we have. We have administrator access. So whatever the orange boxes we see, it's already provided by the Amazon. So we can see that it's the first name is it's a policy. The policy name is administrator access. So the type is AWS managed, used by none. So description is provide a full access to AWS services. So we'll create a new group. We'll just say test internship studio, and we'll create user group. So we already created a test user group, and we'll add the created user to this group. So we'll select this and click next. So tag is always a good practice we need to create. So we'll use the created by tag, and we'll use Shivaling. Since my name is Shivaling, we'll use this. Create user. So congratulations, we already created the first user in AWS, and we also created the first group here. So one thing is, after we created the user group, we can see a warning sign that the permissions is not defined. So we'll go to the group, click on the test internship studio. So in under permissions, go to permissions. So under here we'll attach a sample permission. So we'll go to here. We have two options. One is create inline policy and attach policies. We'll go to attach policies. So here are a couple of predefined policies. So what we'll do here is we'll have a sample. We'll not give the administrator access because it will give the full access. So unless you need the full access, it's not a best practice to give the administrator access. We'll just give the access for S3, which is for managing the buckets. We have selected one, and we'll attach the policies. So it says policies attached to the user group. So what happens is, if I created this group and if I add anyone to any user to this group, they'll automatically inherit the Amazon S3 full access policy. So in AWS, we can see that in AWS IAM, user groups are a way to organize and manage users with similar permissions. Instead of attaching policies directly to the individual users here, we can create these groups and assign the necessary permissions to the group and then add users to the group. because in large enterprises, what happens? There would be, for example, in a organization which has DevOps teams, there would be developers team and operations team. So we can't assign each developer a separate permission. What we can do is we can segregate some permissions required for the developers and add as a developers group. Here we have the internship studio group, right? We can similarly have a developers group, and under the developers group whatever the permissions or policies that developers needs, so we can add all those users who are assigned as developers to this group, so they will inherit all the permissions accordingly. And similarly we can use another group as operations team, and the operations team personnel who all require the required permissions can be assigned to that group. So in a way, this simplifies the management of permissions, especially when dealing with a large number of users with similar access requirements. So like the another breakdown of user groups in AWS is we can use user groups to structure users based on their roles or responsibilities within an organization. For example, you might have groups for administrators, developers, or finance users. So also IAM groups allows us to manage permissions centrally. Instead of configuring permissions for each user individually, you attach policies. As we saw, we attach this AWS S3 full access policy, and all users in that group inherit those permissions. So again, it helps us to simplify access control. When a new user joins the organization or changes roles, you can add or remove them from relevant groups to adjust their permissions. So this simplifies access control and ensures that users have the necessary permissions without manual policy adjustments. Another thing is scalability and maintenance. As your organization grows, management permissions at the group level becomes more scalable and easier to maintain. Adding a user to a group with predefined permissions is more efficient than configuring permissions individually for each user. Policy inheritance. So users inherit the permissions associated with the groups to which they belong. This means that if a user is a member of multiple groups, they inherit the combined set of permissions from all those groups. For example, if I create another group for operations and add a developer in that operations group, that developer will inherit the permissions of both the developer group and the operations group. And policy changes. So when policies change, you can update the group and the changes automatically apply to all users in that group. This helps in ensuring that users consistently have the correct set of permissions. For example, let's see that under policy name, I need to add another permission. For example, I'll attach permissions. For example, if they want to have the access of EC2, so we have EC2 full access. I'll go ahead and attach the policy. EC2 is nothing but a virtual machine access in AWS, which is Elastic Compute Cloud. So it says that policies attached to this user group. So it is as simple as that. Instead of again going to the individual user and assigning this to the developer, we'll go to the group and attach it to the group itself. So here that inheritance of policy becomes easier. So delegation of responsibility is another factor. So delegating permissions through groups allows for a more organized and delegated approach to access management. For instance, a group might be created for specific project team, and members of the team inherit the necessary project related permissions. So there are some other like policy versioning and history. So IAM supports policy versioning and maintains a history of policy changes. This allows you to review and roll back to previous versions if needed, providing an audit trail for changes made to group policies. User groups are not just for managing permissions through the AWS management console. They are also used when working with AWS SDKs and command line interface. So what we saw is to create a group in AWS IAM, we typically perform the following steps. We created the group, we attached the policies to the group, specified the permissions to the group members should have, and we added users to the group. So hope you had an understanding here of how the users and groups work. So the next thing is we saw the user groups, we have users, and the next thing is roles. So an IAM role, it says according to their small snippet, an IAM role is an identity you can create that has specific permissions with credentials that are valid for short durations. So these are some roles which are pre-created already, and we have this roles anywhere option where we can authenticate your non-AWS workloads and securely provide access to AWS services. So we'll do on hands-on here. We'll first create a role. So here we'll use allow AWS service like EC2, Lambda or others to perform actions in this account. So we'll use this service. We'll select the AWS service as the trusted entity type. And we have couple of others like we can allow other AWS accounts. For example, we have this internship studio account, right? If anyone creates some other account, another personal account, we can also authenticate them to do the operations in this AWS account. And there is some web identity. There is SAML 2.0 federation. We have custom trust policy. So we are using AWS service here. So we'll choose commonly used services like EC2 and we'll hit next. So what we need the role to be like do which permission. So we'll do EC2 full access here. Amazon EC2 full access and next. So we'll see the role name. So we'll give EC2 internship studio. So it's a short explanation. It allows each to instances to call AWS services on your behalf. So the trusted identities we have. This is a JSON format document where we have version, we have statement. The statement contains two parameters, which is effect, allow. Allow means it by default allows the action of assume role. And the principal, we have the service, which is EC2. So this is a normal JSON document. So I'll explain the JSON document here. So let's understand what this trust policy does. So the first thing is the version here. As you can see, this is the version. So the version field specifies the version of the trust policy language. So it is set to 2012-10-17, which is the current version for AWS. So next is the statement. So the statement field contains an array of one or more statements, each of which defines a trust relationship. So next one is the effect. So the effect field specifies whether the statement allows or denies the specified actions. It can be set to allow or deny. So in our case, since we are using the EC2 full access, we are making it to allow. So next comes the principal here below. So the principal field defines the AWS account or service principal that it is trusted to assume the role. So it can also specify federated users or applications. So next is the action. So the action field lists the AWS service or services for which the trust relationship is established. It specifies the actions that the trusted entity is allowed to perform. So this is how our JSON policy is looking. And next we already added the permissions. So it's also best policy to create the tags always. I will do created by. I'll use internship studio. And we here create the role here. Sorry, I just, yeah. So only these characters are involved here, not the slash one. So by mistake I had enter the slash two times. I think now we should be good to go. We'll go ahead and create the role. So here we can see our first role being created. So we just went ahead and created a role with the EC2 full access policy. And next one, after doing the AWS user group, users and roles, we'll next go ahead and hit the policies. So in AWS and access management, identity and access management, policies are JSON documents that define permissions and control access to AWS resources. So policies specify the actions allowed or denied, the resources to which the actions apply, and the conditions under which those actions are allowed or designed. Here are key components and concepts related to policies in AWS. For example, if we go to the S3 related policy, I'll type S3 and click enter here. So we'll have the S3 full access. So go ahead and click on that. So we'll go to the service S3 and we have this all sorts of permissions here. So we have this describe job, we have this describe multi-region access point. So there are multiple policies attached. So this is a summary, and to this is just the overview. Like we have a human readable format, but we also have the JSON related format. So you can see the JSON related format of the policy here. So each policy we find in AWS has this JSON related object. So we can customize this. So this is pre-built for the S3 object Lambda. Lambda is a serverless offering from AWS actually. We'll deep dive into it when we come to the Lambda service. For now, understand that we can define whatever policies in this JSON format. Yeah, this was our pretty much hands-on session. Like we learned how to create a user, and we learned how to create a group, and we also learned how to create a role, and we learned how to create a policy as well. And we also learned how to attach a user to a group. So coming back to our presentation, so we are done with the hands-on. So we'll first understand after hands-on lab what are identities here. So identities here can be a user. User in the sense it may be a person or a service. For example, S3. There can be user types. Uh, there are mostly three types of users in AWS. The first one is the root user. The second one is the individual user, and the third one is the federated user. So the root user has the most control. He is a super admin. Like you can imagine him has to be a superhero. Like he has all the access. He can do whatever you want in the account. Uh, that is the main thing about the root user. So it's always recommended that we should always operate via the individual user method. For example, IAM method. So it's mostly very safe in that sense, so that we don't do much of the privileged operations in the AWS. So to understand in a more better way, so the root user is the initial account owner created when an AWS account is set up. So I have actually, while showing you the hands-on session, I have logged in as a root user. So this user has complete administrative access to all AWS resources within the account. So the root user has unrestricted permissions, which means his he can do whatever he wants. So his actions are not restricted, and it should be used only for initial account setup. So it's recommended from AWS that you only use the AWS root user account to just log in for the first time, and it also recommended for very limited administrative tasks. So it is highly recommended not to use the root user for your day-to-day operations. Like once you create the account and set up all the related activities, so you can just create another IAM user and just operate on your day-to-day activities on that account. So the next is the individual user account. So the individual users are additional IAM users created within an AWS account. So IAM users have specific permissions and can be assigned policies that grant access to resources and actions. Unlike the root user, IAM users have controlled and customizable permissions, allowing organizations to follow the principle of least privilege, granting users only the permissions necessary for their tasks. So creating IAM users is a best practice to manage access securely, audit activities, and enforce separation of duties. So each user has a unique set of credentials, username and password, or access keys for authentication. So the next one is a federated user. So federated users are users who gain temporary access to AWS resources by assuming a role through an external identity provider. So that IDP may be from Microsoft, Azure Active Directory, or a Google Authenticator. So this external IDP could be a corporate directory, a SAML based identity provider, or a social identity provider like Google or Facebook. So federation enables users to sign in with their existing credentials from their trusted source. Once authenticated, federated users can assume roles in AWS that have specific permissions. This allows organizations to extend their existing identity systems to AWS, promoting a single sign-on experience. For example, if a company is already using Microsoft Azure Active Directory, they need not face problems when moving to AWS. So this makes a easy authentication experience for them. So the next important point is federated users do not have permanent IAM credentials. Like for example the root account has or a IAM user has. So federated users do not come with a permanent IAM credentials. Instead, they obtain temporary security credentials when they assume a role. So these credentials are valid for a limited duration and are automatically rotated. So these are some important points about the user types. So the next, these are uh, the main aspects of the identities part. The next part is what is the principle of least privilege. So the principle of least privilege is a security concept that suggests that entities such as users, processes, or systems should be granted the minimum level of access or permissions necessary to perform their job functions or tasks. In other words, individual or systems should have the least amount of privilege required to accomplish their specific roles and responsibilities. So the goal is to reduce the potential impact of accidental mishaps, errors, or intentional malicious activities. So actually you have heard of POLP because it's a fundamental concept in cybersecurity and access management, including within AWS. So what it advocates is granting individuals or systems the minimum levels of access or permissions needed to perform their job functions and no more. The idea is to reduce potential impact of accidental mishaps or intentional malicious activities by limiting access to only what is necessary for a specific role or task. So for example, we have created an IAM user group and role in our previous like some around some time back, right? So we should define IAM entities, either users, groups, or roles with the least set of permissions required to fulfill their responsibilities. For example, if a person wants to create S3 bucket, he needs to have only what it takes to create a S3. You should not have the permissions for network related activities or virtual machine EC2 related activities. It should only have permission for the S3 related activities, and also granular permissions. So IAM policies allow for granular control or permissions, specifically exactly what actions are allowed or denied and on what resources. For example, rather than giving full access to an S3 bucket, provide permissions only for specific actions like S3 colon put object or S3 colon get object on a particular bucket. So I hope you had an overview of what the principle of least privilege is. So going to our next slide. What are groups in AWS IAM? So we already explained what we saw. Groups are nothing but logical collections of IAM users. So we can segregate each users logically according to their prescribed role. So each IAM user can be a member of multiple groups. For example, we had created a test internship studio group, and we had added an user called internship studio test user. So we can also create another group and also add him to that group also. So another point is groups simplify permission management by allowing you to apply policies to a group of users rather than individually. As we saw, we can attach policy directly to the group instead of assigning them individually. So groups play a key role in implementing the principle of least privilege by organizing users based on their roles and responsibilities. As we saw, they will advocate for the implementation of principle of least privilege. So they help in streamlining access management by assigning permissions to groups rather than individual users. So they help ease the process of access management actually. You can see that assigning policies individually to a user is a very tedious process. So in that case, so groups play important role in streamlining the access management. So groups are commonly used to organize users based on job functions such as administrators, developers, or finance. So as you can see, we can logically segregate the users according to their job functions. They are effective in scenarios where multiple users need similar access rights to AWS resources. So if in large organizations they have teams of hundreds of developers, operations team, so it becomes very logical to put them in terms of groups. So this is an overview and explanation of the groups. So there are other types of access management AWS. We have the concept of policies, policy types and roles. We already saw what these policies, policy types and roles are in our hands-on session. So yeah, thank you for attending the session. So in this session, we already covered AWS IAM. We got an overview of what AWS IAM is. We got to know the creation of roles and groups and adding users, the creation of users and adding the user to the group. So we also understood the principle of least privilege, and also we understood the root user management, and we also configured MFA for the root user. Hope you had got information, and hope this session was an informative one. So in the next session, we'll be covering the AWS S3, which is a simple storage service. Once again, I thank you for attending the session. Bye and see you in the next session.